All right, guys. So in the other videos that we looked at with geologic time, we largely looked at page 8 and 9 in the reference table. And one of the things that I wanted to do was share with you a book called Life Story. And I'll read much of the book, probably not the entire thing, but much of it. And it really brings you through Cambrian time, or actually pre-Cambrian time, up to our current time, Cenozoic. So it's really just kind of a fun storybook, and the illustrations are kind of nice. They set it up as if this whole life story is a play or like a theater play. And there's a stage. So this will be kind of a different lesson today. We'll take a little bit of time to just read a story called Life Story. And again, the idea of the book is life story is sort of set up like a play. Let's skip right to the story. Okay, so I'm going to just sort of abbreviate some of it because it would take a long time to read the whole book. I will read sections of it. And here what we're being shown is the Milky Way galaxy. And that's something that we'll talk about when we do astronomy next. And what they're showing here with this telescope is our position within our galaxy. This is our sun, our star. Earth would be nearby along with the planets that you know, Mercury, Venus, and so on. And we live in a spiral type galaxy called the Milky Way. And that's our position in space. And that's something that we'll talk about more when we do astronomy. Here is showing the formation of our solar system. We have the sun, we have the planets, Mercury, Venus, Earth, Mars, and so on. And we can see that the planets were molten balls of melted material, essentially. Thousands of millions of years ago, our Earth was a red, hot, fiery ball of matter, surrounded by clouds of dust and swirling gases. And that's what that's showing here. Some say it was a separate and smaller ball of matter, but nobody really knows because there was nobody there. Anyway, our moon circles our Earth about once a month, or to be exact, every 29.5 days. And we'll talk about these things when we do astronomy. Really what I want to get into is life. Way back in time when our Earth was young, no life could have lived on it. Its surface was a red-hot sea of lava, and its center was white-hot liquid rock. Thick clouds of steam, dust, and gases hid the sun. Flaming hot meteorites from outer space bombarded it. Hundreds and thousands and millions of years passed by, and gradually the surface of our Earth began to cool. As it cooled, it hardened to a thin crust of rock. Rocks that have solidified from liquid conditions are called igneous rocks, or fire-made rocks. Heat from the interior caused Earth's crust to move across its surface, forming great high mountains, low valleys, and deep ocean basins. Life may have been present at this time, but there is no record of it. So we're in that Precambrian time period where there's, or Precambrian eon, I guess I should say, where there's no record of life on Earth. From the beginning, the clouds opened, rain poured down in torrents on the now cooled surface of our Earth, filling the ocean basins and wearing down the mountains. Rivers and streams carried little particles of rock down and deposited them in layers on the floors of the oceans. In time, these layers of sand, gravel, and clay hardened into rock called sedimentary rock. Life was present, as was recorded in fossils of tiny cells and chemical signatures of microorganisms that covered the Earth. And now we really get into the Cambrian period. And now we really have our Cambrian explosion. We have our soft-bodied creatures like we looked at before. The scene is laid underwater, so this represents the seafloor. The story is based on the record of fossils found in sedimentary rocks 500 million years old. The ancient life of this time was made up of sea plants and little animals without backbones called invertebrates. The most highly developed of these ancient animals were the trilobites. There's a little plastic trilobite. They ruled the seas for 100 million years. There's a bunch of different ones. Many different species of trilobites. So that's the Cambrian period. Life existed. underwater, Cambrian explosion. Now we get into the Ordovician. Life continued in the warm, shallow seas. Although there were still trilobites, their rule was over. Other kinds of invertebrate sea animals called cephalopods, which would be like squid and octopus, now played the leading role. The name cephalopod simply means having feet on the head, meaning like tentacles. Squid and octopus of today belong to the same family. Fish, which first swam in Cambrian oceans, grew more abundant. Little lichens and simple moss-like forms lived on land, the pioneers of the plant world. So we can see the lichens and mosses on the land. But again, most life is underwater, and there's the trilobite and our cephalopods, our squid and octopus-like creatures. And we're moving up that geologic timescale. Now we're in the Silurian time. The scene changed as the land slowly rose. The seas retreated or evaporated, leaving salt deposits. On land, the ancestors of mosses were joined by the earliest ancestors of the ferns and seed plants that would later cover the continents. The cephalopods had decreased in size and in number. Sea scorpions, again Eurypterids, New York State fossil, had taken over the rule of the seas. More fish appeared on the scene. The first animals to have backbones called vertebrates. So fish were believed to be the first vertebrates. Now we're in Devonian seas. This is really where New York State comes into play. We have probably more Devonian fossils than probably anywhere else that I know of anyway. Land plants flourished, clothing our once bare earth in green. Ferns made their first appearance at this time. Also early forms of horsetails, club mosses, and scale trees. These plants, instead of creeping along close to the ground, had roots of their own, stems and leaves, and stood up reaching for the life-giving warmth and light of our sun. Seas, lakes, rivers, and streams swarmed with fish, big fish, little fish, and medium-sized fish. A few even developed lungs and crawled from puddle to puddle on land. Late in this period, the first land vertebrates appeared. We can see all of the fish. Sometimes the Devonian period is referred to as the age of the fish. Now we're in the Carboniferous period, and we can see these coal-forming tropical swamps. While on some parts of Earth there were glaciers and an ice age, on much of the planet the land was low, the climate warm and moist. Great swamp forests covered much of our Earth. This period is called the Age of Plants, or the Coal Age, because most of the coal we use today comes from these ancient plants. Amphibians, another kind of vertebrate, appeared on the scene. Here we can see these large amphibians. They were animals that lived their early life in the water and their adult life on land, like the frogs of today. Insects were present and abundant. Now we're into the Permian period. And I should have said this at the beginning, but it would probably be a good idea to have your reference table out with you as you look at this and follow along with the time periods. Now the mountains and volcanoes rose high. The climate in North America and Europe turned dry. Life, in order to survive, was forced to adapt or to change. Hardy seed-bearing conifers replaced the swamp trees. Land-living reptiles displaced the amphibians. Reptiles lay hard-shelled eggs on dry land. Amphibians lay soft eggs in the water. At the end of this period came a crisis in our Earth history. A mass extinction, probably caused by an excess of volcanic eruptions, took place. So at the end of the Permian, we have our first and most significant mass extinction event on the Earth. More species perished and died than the mass extinction event that killed the dinosaurs. It's believed that 90% of life on Earth at that time went extinct. Now we're into the Triassic period, and now we're getting into the age of the dinosaur. The climate grew warmer. Streams and rivers eroded the mountains. Reptiles continued to play the leading roles. Early mammals and dinosaurs, members of the reptile family, appeared on the scene. Dinosaurs, instead of crawling on their stomachs, stood up and walked on 4 legs or on 2. A few of the reptiles returned to a life in the water. We have large marine reptiles like plesiosaurs and ichthyosaurs. A lot of people think they're dinosaurs, but they're actually large reptiles. Now we're in the Jurassic period. Once again, the climate was warm and moist. Some of the plant-eating dinosaurs had grown tremendous. Some had developed armor for protection from their meat-eating cousins. Some reptiles had learned how to fly. The first real bird appeared. Little mammals were present, but they played a very small part at this time. Now we're into the Cretaceous period. This is the last time period in the Mesozoic when dinosaurs existed. You can see the large pterosaurs and T-Rex, of course. Mountains were slowly rising. Shallow seas flooded the lowlands. On land, in the sea, and in the air, the reptiles ruled. Now flowering plants appeared for the first time. Mountains continued to rise. We're still in the Cretaceous period. The climate grew colder and colder. The shallow seas retreated. On the very last day of this period, a 10-kilometer wide meteor hit the Earth. This catastrophic event brought about the extinction of species upon species of dinosaur, never to be seen on Earth again, except as fossils in museums of natural history. The scene has changed. The climate had turned hot and humid. Dense tropical forests covered most of the lowlands. The few survivors of the reptile family now played a minor role. Now we're in the Paleogene. We're in the Cenozoic era, modern time, and now mammals are beginning to dominate. Mammals bear their young alive and take care of them until they are old enough to take care of themselves. Both birds and mammals are warm-blooded animals, while all others are cold-blooded. So now we're in Cenozoic, recent times. We're in the Paleogene period, if you're following along with your reference table. The climate grew a little cooler and drier. True grasses increased and spread at this time. They are members of the great family of flowering plants. Mammals were developing and experimenting in various forms, all kinds of rhinoceros and horses. Although they were the ancestors of our present mammals, it is difficult to recognize some of them. Now we're in the Neogene. The climate grew steadily warmer. Grasses spread rapidly, making open plains instead of forests. Plant eaters changed their diet of leaves to one of grass. The rule of the mammals was now at its height. A few of them grew big and tall, the largest land mammals of all time. The climate of North America had begun to cool, and glaciers began to spread in parts of North America. However, the climate of most of North America and Europe was still fairly warm, and animal life began to look more like the mammals we know today. We're in the Neogene period by today. And now we have elephants and horses and camels and saber-toothed cats, similar to lions and tigers and so on. And now we're in the Quaternary period. In the north, great glaciers formed and slowly moved southward, scraping the land bare. This time in life's history on Earth is called the Ice Age. These great masses of ice advanced and melted and retreated multiple times. Humans were present at this time, but played a very minor role. The appearance of humans on the scene happened only a short time ago as compared to the long length of time that all other life had been present. Prehistoric humans lived in caves and discovered the use of fire. They made tools and weapons of stone or pieces of bone. They hunted the wild animals for food and clothing, and they painted pictures of these animals on the walls of their caves. And now we start getting into more recent times. Native Americans, you can see in the background, probably Christopher Columbus's ship discovering the New World. And if we keep going along, we see humans really develop agriculture. And this is all within the last 10,000 years. So the Cenozoic time period brings us right up to recent time. And we can see people farming. Now we're really into social studies more than earth science. We can see, people buying houses and living in a more modern lifestyle. And that's really the end. So I really just kind of wanted to use this book as a way to walk you through Earth history.